Good afternoon and welcome to EV webinar number 4, Future Innovations in Electric Transportation, presented by Lincoln Electric System. I'm Marc Shkolnick, Manager of Energy Services, and I'd like to thank you for sharing part of your day with us, learning about and discussing the future of electric transportation. The electric transportation space is quickly evolving on a global scale. While the pandemic may be slowing the pace of change in the short term, it appears the inertia of electrified transportation will continue moving forward. Today, we're going to spend time contemplating what the future may bring. Before we start, let's review just a couple of housekeeping details. First of all, this webinar is in listen and view only mode. So if you do have any questions throughout the presentation, feel free to use the chat box option, which I'll be covering here in just a moment. The webinar is being recorded and will be available for replay at our les.com/EV site within the next 24 or 48 hours. To use that Q&A function, you simply click on the Q&A button at the bottom of your screen on the toolbar that should appear, and you will be prompted with this chat box. You just simply enter your question in and hit send, and then we'll have the question available for the question and answer period, which will come at the end of the presentation. So before I introduce our presenter today, I thought that we would begin with some interactive poll questions that will kind of touch on some of the themes that Marc Kosowski is going to address during his presentation. The first couple of questions I'm going to ask you to respond to have to do with improvements in electric vehicles that you'd like to see. So let's put the poll out there. You should see the questions on your screen. The first question is, what improvement would you most want to see for electric vehicles? Faster charging, longer range, more vehicle models available, lower vehicle costs, or other. And the second question is, if available, what model of EV would you most likely want to purchase in the future? Go ahead and respond to those two poll questions, and I will share the results in just a moment. Okay, everybody's just about responded to everything, so I'm going to end this poll and share the results. So for the first question, more vehicle models is a strong preference among a third of you. Lower vehicle costs and longer range are also in the top 3. Faster charging, not quite as important. That's a good item because we're going to be talking about some of the pickups and other types of vehicles that we expect to hit the market in the next couple of years. Interestingly enough, as we look at the second question, the SUV crossover, over half of you indicated that's the model you'd like to purchase in the future, with a pickup at 21%. So 73% of you would like to see SUVs, crossovers, and pickups, which is interesting because about 70 to 75% of the vehicles on the road fall into those categories. So that's a very popular model, and it's probably where the electric vehicle market needs to move to be able to capture a much larger share of the overall driving market. So that's very interesting results. Let's look at another question that I would provide to you here. And this has to do with ideal battery driving range. So respond to this poll question. The ideal EV battery driving range that would meet my needs would be 30 to 50 miles, 100 to 200 miles, 200 to 300 miles, 300, 400, or more than 500 miles. I'll pause and give you a moment to respond. Okay, let's share the results here. So almost half of you are looking for ranges in the 300 to 400 mile range. And there are a scant few at this time that can provide that range, although the market is probably heading in that direction. But there are plenty of all-electric vehicles that provide 200 to 300 miles of range, as well as the 100 to 200 mile range. Those who are looking to 30 to 50 miles, the 6%, certainly the plug-in hybrid range on its own would be able to capture a lot of that, at least the more recent models. The last question I'd like to pose before we get into our presentation has to do with autonomous vehicles. The likelihood that I would frequently use an autonomous vehicle service, if offered, should be if offered, would be highly likely, somewhat likely, occasionally, somewhat unlikely, or not likely at all. We'll just have a few more seconds on this poll question, and then I'll share the results. Okay, let's share what feedback we got here. So about a third of you said you would not use an autonomous service if offered. You know, the fact that we're in Lincoln and getting around town is by and large something we would do either driving, maybe bicycling. That's probably not too surprising, although 2/3 of you said that you would at least consider the autonomous service if available. And at least half of you said you would do it on an occasional basis, if not more. So for at least this group of people, you're open to the idea of autonomous vehicles providing a service here in town. So that's good precursor to our presentation today. And I'm happy to introduce our guest speaker today. That is Marc Kosowski. I'm delighted to introduce Marc. He is technical executive at the Electric Power Research Institute and a veteran of the automotive industry. Marc oversees research and activities related to standards in public charging infrastructure with expertise in bus and medium-duty electric transportation. Prior to joining EPRI in 2009, Kosowski held the position of Assistant Chief Engineer of Hybrids at General Motors. Kosowski worked at GM for almost 40 years. He worked on the Volt, Precept, EV1, engine controls, and other automotive developments. Marc, let's turn things over to you.
Thanks, Marc.
Thank you.
Okay. Again, I'm glad to be here to talk about future innovations of electric transportation. I'm going to speak. I got a lot of presentation here, and so I'm going to begin and move on. Let's just get set here. The agenda for today, I do want to talk about new EV truck models that are coming. They're not quite out there yet, but we'll go through that. I also want to talk about the evolution of battery technology, where we've been and where we're at now, as well as some new developments in mass transit. We'll talk about some mass transit buses, as well as actually look at some fleets and doing what they're doing. And then finally, we'll talk about the future of autonomous vehicles. The first thing is we're going to talk about the new EV trucks, the crossovers, pickups, and SUVs. And as you can see, there's quite a few models coming out. We'll go through these in just a moment. And the big deal here is electric trucks are coming soon. They all the OEMs are working trucks, and I think they'll be out there very, very soon. Let's begin now with all electric trucks available in 2021, say next year. First of all, Rivian. Rivian has their R1T. Rivian's a brand new company that is now located in the Detroit area. They're going to have a 230 to 400 mile range, dependent on their battery size. The biggest battery they're going to have is 180 kilowatt hours, and then there's two other smaller batteries. They will have a 0 to 60 of less than 6 seconds, and the price tag is $70,000 to $80,000 for the truck. Bollinger B2, again, they have a 120 kilowatt hour battery, and their vehicle will go about 200 miles. They've got a 450 kilowatt motor, and they will be lighting off their tires at about 4.5 seconds for the 0 to 60. Their price tag is quite pricey at $125,000. The all electrics available in 2021, the Ford 150 will be coming out in 2021 with about a 300 mile range. There is not much real information out there for the 150, except that it will be there. Mercedes has the EQC coming out, an SUV that has an 80 kilowatt hour battery and can go 200 miles. And again, all of these all have a rather quick 0 to 60, less than 5 seconds 0 to 60 on this one. Then Ford is also bringing out their Ford Transit cargo van as an all-electric in 2022. General Motors is bringing out the Hummer. The Hummer there'll be two different models, a model SUT, which is the truck, sport utility truck, and also a sport utility vehicle. It will have an 800 volt battery. Typically vehicles today are about 400 volts. And so most of these vehicles, because they're toting so much range, that they're going to be much higher voltage. They will be able to fast charge at 350 kilowatts, and the Hummer is going to come in at about $70,000. Cadillac Lyriq is an SUV that Cadillac will be bringing out in 2022, and it's a $75,000 vehicle. You've probably heard about the Tesla Cybertruck. Here it is pictured, and again, 200 kilowatt hours of usable battery. They're expecting to get 465 miles of range. Their consumption is 0.42 kilowatt hours per mile. Myself, I question how low that is. I think it might be too low, but that's yet to be seen. They're also looking at the price tag being between $39,000 and $69,000, which will probably depend on the amount of battery is in the truck. And then in 2023, Chevrolet will deliver their pickup truck with 400 miles of range and an 800 volt battery. I would imagine that the powertrain is going to be just like the Hummer, probably on the same chassis. This will be the pickup though. Now, changing from all electric to plug-in hybrids. A plug-in hybrid basically has both an engine and a electric machine. And so basically you can go so far with electric and then the engine turns on. The Lordstown Endurance is it's a brand new company. They'll be making it out of the Lordstown plant where GM had for years. They've got a 60 kilowatt hour battery. They've also got a 2-cylinder engine, and their range will be about 310 miles with the engine. They don't they didn't categorize what their electric range was going to be. They've also got what they call export power. Basically, you can now plug in appliances up to 7 kilowatts and actually run those out in the field from the battery and or the engine itself. They've got a 6-second 0 to 60 and a $52,000 price tag. Nikola, on the other hand, is they're going to be producing the Badger. The Badger comes in 2 different flavors. One as a battery electric vehicle, but the other then is as a fuel cell electric vehicle. The fuel cell electric vehicle will have 160 kilowatt hours of battery and will be capable of going 600 miles of range. The BEV will only go 300 miles. And as you can see, they're under a 3-second 0 to 60. Toyota will bring out their RAV4 as a plug-in. They've got their 2.5-liter 4-cylinder Atkinson engine in it. They plan on getting 39 miles of electric range, and they'll get 90 miles per gallon equivalent on the EPA economy test. They're talking about less than a 6-second 0 to 60, and they're going to be starting out at $39,000. In summary, here's a summary that takes all that data I just went through and categorizes it by year and the different companies, as well as some extra data. You can see that there are some holes in the data. It's just not available. So now I'd like to go to the next topic. Next topic is evolution of battery technology. Chargeable batteries have been around for a while. Some of the original ones were NiCads, but this particular graph, if you can, the bottom line is energy. Energy is the amount of, is similar to the amount of water in the tank, or say fuel in a tank. It's the amount of energy a battery holds totally. Whereas the specific power, which is the y-axis, it's the amount of power you can get out of the battery. And then basically it's hooked to that tank of water. And if you got a small garden hose, you're not going to get very much out. Whereas if indeed you put a fire hose on it, you're going to get a lot of water real quick. And so you look at lead acid batteries. Lead acid batteries are very heavy, and again, they do not they don't have the energy that a lithium ion battery has, or that a nickel metal hydride pack has. And you can also see as it's going up this way, again, there's more energy as well as more power. Power is what's used to get the vehicle down the road, and the energy is what's used to how far the vehicle can go. Now, if you look at the battery evolution for vehicles, if you down here in the bottom is recombinant lead acid. Recombinant means it's quite rechargeable. Then there's nickel metal hydride, and then there's lithium ion. Just to point out, back in 1990, the GM Impact that I fathered pretty much, it started out at 16 kilowatt hours with a recombinant lead acid battery. The vehicle weight, the battery was 40% of the entire mass of the vehicle. So you had to make the vehicle small. Several years later, we did in 1996, we went into production with the GM EV1. It had a better recombinant lead acid battery. About a year after that, we then went with the nickel metal hydride pack into the EV1. And then we actually went through a hiatus of about a decade between 1997 or late 90s to 2010 when the GM Volt as well as the Nissan Leaf came out. The Volt being a plug-in hybrid, and the Nissan Leaf being an all electric. 2 years after that, then Tesla Model S came out, and you can see that their batteries got bigger, 65 to 85. And then right after that, or in 2016, the GM Bolt came out with 60 kilowatt hours. The Tesla Model 3 came out with, and again, 75 kilowatt hours. And again, the plan then is to bring out the Tesla Cybertruck, which will have more than 200 kilowatt hours in it 2 years from now. Now I'd like to switch topics slightly, and let's go to the development of mass transit buses and fleets. The U.S. Bus fleets, this was at the end of 2019. There were 168 different known transit programs in the United States. They were contained in 46 states. They were at airports, they were at universities, they were privately owned fleets. Electric buses cost about $200,000 more than a diesel alternative. But in theory, they are estimated to save $400,000 in fuel and maintenance over their 12-year, 500,000-mile lifespan. And also, each one of these buses basically can actually be equivalent to removing 27 automobiles from the road. In Greensboro, South Carolina, they plan on saving $350,000 in fuel over the 12-year life. And then 82% of these fleets is federally funded. So our United States government, through the FTA, pays for most of these buses. Why do we want battery electric buses? Well, first of all, there's the air quality concerns, diesel belching out at going down the road. There's the operational maintenance savings. There's the being environmentally responsible, policy and regulation requirements, and then also the reduction of noise. There's a host of cities that are planning in the next couple years to the next 20 years of actually taking their fleets and making them all electric. Electric buses, again, this is where all those fleets are. You can see there's 39 of them in the state of California. The next one is Colorado, which has 10. And then you can see that the rest of the country has onesie twosies all the way across. There's only 2 or 3 states that are not there. There's also solar examples. These are some fleets that actually have solar power powering some of their vehicles. Let's get into automatic charging, conductive and inductive. This is very important for a fleet. And back in January of this year, a recommended practice by SAE was published. I am the committee chair for this, and basically we met for 4 years trying to get this thing through, meeting with bus companies, fleets, charger companies, etc. It was an accomplishment. But basically, when you charge a bus, there are only 4 conductors. Again, there's 2 DC conductors, there's a ground, and there's finally what we call a control pilot. That's how we communicate. And then what we've established is there's actually 3 different connectors. One connector is the bus actually comes underneath this infrastructure, And this infrastructure, this pantograph above, actually then comes down onto the bus with cross rails. So this one's called the infrastructure mounted cross rail connection. We also have a vehicle mounted pantograph connection. It has the same connections as described in 3105, and however, it now goes up and attaches to the hood above. And again, there's advantages to each. This tends to be the European variety. The US variety tends to be this first one. And then also the enclosed pin and socket in the side of the vehicle, and this is actually being used on docks right now, but there is a cone, and as you get it close, the actual pin comes out, and the funnel forces it down into a hole where there's 4 conductors. With this one, we can actually charge the vehicle out up to 1 megawatt. Now there's one, so that's conductive. There's also wireless or inductive charging. This has been in business. They've been in business now for a couple of years in Long Beach. This is a picture I took in Long Beach, and there's a pad here out in the middle of the street. And what happens, the bus actually comes and lines up and parks over that for 10 minutes. And what happens is, over a 8 to 10 inch gap, electricity flows from the ground into the bus and charges the batteries. This is done at 50 kilowatts. Currently in Antelope Valley in California, they are using this up to 250 kilowatts, which they now get 5 times the power. This is the actual charger in the foreground. It's hidden behind a fence, but it's there to provide the power to the pad. Now, looking at some electric transit buses, this is New Flyer, and you can see New Flyer, as you know, they have the infrastructure mounted pantograph. All buses do use a manual connector. There's so many times they're in a maintenance garage and they just need to be charged, so they use a manual connector to do that. They're tending now to use, again, some sort of automated conductive. And then this bus here is made by BYD, and it has a 250 kilowatt charger underneath it currently, being able to charge that. The all-electric, okay, and then there's a couple others, and here's Solaris. That's a European bus company. Nova is out here now, and again, you can see they're using the same overhead. Gillig is now producing vehicles, as well as Proterra. VDL in Europe, they are producing vehicles, and we'll look at more of these in just a moment. And then the Phoebus hydrogen, this is actually in Europe, and it's running on hydrogen. Now, just to switch gears one more time, and that is Amsterdam Schiphol fleet. I want to talk about a fleet and what they've done. Schiphol is the airport in Amsterdam, the Netherlands. 2 years ago, they put in 100 60-foot transit buses made by VDL. As you can see in this picture, these 5 are actually charged at 450 kilowatts. They come in for a 10 or 15 minute charge, and they're back out on the street again. Where these, there's 5 of them here with the hoods above, they're being charged at 30 kilowatts per charger. You can also see this bank of chargers all the way down. They're chargers that are in the center between the 5 on this side and the 5 on that side. They do run a 24-hour service, and they have 6 different lines that the buses run on, and they get more than 18,000 miles per day, meaning they get about 6.8 million miles per year. Now, just overlooking that depot, the picture you just saw were these very first ones. There's the 10 of them. You can see how far back they're all stacked up. Here at this depot, they have 48 30 kilowatt chargers and 5 450 kilowatt chargers. And they also have 5 independent transformers for resilience. In case one goes down, they can still power the thing. Then overlooking their opportunity charger, this is, they have four buses coming into this thing. You can actually see the 4 buses in this area. There's 2 buses waiting, but so the buses come in here, the chargers are right here, and then the transformers are just across this way, and they have 2 of them there for, again, resilience. And then the chargers look like this. A charger, a 450 kilowatt charger, is $330,000. So you can see they've got some money tied up here. And then what their little plaza looks like is, here's the bus coming in underneath the 4 hoods. Here's the chargers, and then here's the transformers on this side. They got power going underneath, coming up into the chargers. The chargers then produce AC power for the buses. This is actual Schiphol. You can see this is the airport, and what they have is there's a depot out here. The depot I just showed you is right here, along with the en route charging right here, and then right in the center of the terminal they have another en route charging, so that the vehicle, so the buses, when they need a charge, they stop there and charge for 10 or 15 minutes. Now I want to be able to show, this is how it actually works. Basically what we have, the bus pulls in, and then the pantograph goes up and connects, and charge begins. The indoor charging, and again, what I want to show here, the first one was outdoor, this one's indoor. Eindhoven is about an hour south of Amsterdam, and you can see that all the buses are under a roof, and there's 43 of these here. The operator aligns a yellow mark in the bus door to a white line here, and if they get it within a couple feet of that, they're in position for charging. Now, this is actually an en route system. You can also see that the buses are coming in, and then on this particular one, they have stops. They have stops for the wheels. So when the wheel hits the stop, they know they're in line for charging. The indoor depot looks like this. This is the back side of it. And on the right side of the picture, there's all the chargers. But they've still got a lot of room for more buses if they need to. Here, the charger cabinets, power comes in the bottom, and then you can see them, the power then, the DC power then goes out the conduit over to the hoods. Now, quickly, just looking at Santiago, Chile, they are quite electric. They have 285 BYD buses that are electric, and they have a total of 386. you can see that the buses are underneath solar panels, and they're just parked hither and to. Now, just changing to the last subject, autonomous vehicles. Self-driving cars are known as autonomous vehicles and are key innovation in the auto industry. There's a high growth potential. It's the actual development is acting as a catalyst for technological developments for the automobile. Currently, this year, there's an estimated need for 6,700 vehicles like this. And then by 2030, they expect to have a 63% higher demand for those vehicles. The autonomous vehicles, you may have seen some in Arizona in particular, but they have these bricks on top. Most of the large OEMs have autonomous development vehicles for experimentation. The equipment on the roof will be contained within the production vehicle. So all of this equipment needs to be tucked in the vehicle someplace. All the large OEMs have developed autonomous vehicles for decades. I remember being with General Motors back in the late 90s with Toyota and Honda and Ford. And basically we closed up some highways in Southern California and spent a week just playing with autonomous vehicles at that time. And again, that was 20 years ago. Now, many sensors are required to understand the adjacent traffic and pedestrians. And so all these vehicles are pinging off of other vehicles. And to do this, though, there is a significant amount of computing power on board the vehicle. And that means there's a lot of electricity too. So this will take a lot of battery energy. The other thing is the systems. You need a brake-by-wire system, a steer-by-wire system, and a propulsion-by-wire are all definite must to have. Now I'd like to talk about the American Center for Mobility. The ACM is a nonprofit product development facility for future mobility. It enables testing, self-validation, and certification of connected and automated vehicles. It's located in southeastern Michigan on 500 acres. They have simulation of virtually any driving conditions: snow, sun, rain, sleet. They have an extensive network infrastructure. And again, they're equipped and enable a combination of simulation, track testing, and on-road testing. This is the map of the facility. And basically, what they have is automakers bring their vehicles here for a week, or they have long-term garages where you can stay there for months. But basically, you have all kind of different road systems. You have traffic lights. You have roundabouts that you can use. There's a highway loop. They have an urban canyon, parking, the whole shot. It's quite a facility. Well, I had the opportunity last fall to actually come to this thing. This is their tunnel, and I think it's a great thing for development. While I was there, they did have a braking demo, and what I want to show here is you see the vehicle in front of you, but to its left there's another vehicle. Both vehicles have no operator, but they are in autonomous mode. And so the white car will take off all by itself, and then the Honda behind it will come up and hopefully stop. Oh, it didn't stop. But so basically what you want there, if I look at those two vehicles, the rearward one was a Honda, and it has an automatic steering and braking and accelerating system that it takes over and goes. The vehicle in front happens to be a Faux robotic vehicle that's capable of steering, braking, accelerating, and speeds up to 65 miles an hour. You can see on the bottom of it, you can see this little sled. Well, what we have is, here's the platform after it got demolished. This platform is about 3 inches tall. It's as long as the vehicle, and basically has steerable wheels, has GPS in it, and other instrumentation, has a battery pack, and again can go up to about 65 miles an hour. All the black stripes there are Velcro stripe, or actually Velcro tape. And so then it took these gentlemen in yellow, it took them about 10 or 12 minutes to actually put this vehicle back together. You can see that the tires are already flat because they don't rotate. And basically this, the signature for this vehicle is just, from a radar perspective, is just like a real vehicle. So it really thinks it's a real vehicle. This way development can happen without any danger of personnel or crashing too many cars. Now let's try the experiment again. Here's the same vehicle. Here's that same vehicle and the same Honda coming up behind it. This time it's not moving, but hopefully it stops, which it does. They have other vehicles there. They have bicycles and scooters and pedestrians. These are all mixed in with vehicles. And one last bit, the property that it's on was actually the bomber plant at Willow Run in the early 1940s. The Ford Motor Car Company built this factory, which had 40,000 people in it at Willow Run. It had an airport, and there, during the war, they made 8,600 B-24 Liberator bombers. And you can actually see the bombers being made here. And then you've heard of Rosie the Riveter. Well, here she is. Again, it's a 5 million square foot manufacturing plant. There's a major airport there that's still used today. And basically the planes would come off the end of the line. There would be a pilot there, and the pilot would then fly them away. At the end of the war, they were making one plane every hour. And then General Motors did buy the transmission plant. They were making transmissions at a rate of about 35,000 transmissions a day. And the Volt transaxle was made there. It was actually designed and tested there. Finally, in summary, we previewed the future of electric vehicles. We took a quick look at the evolution of batteries. We learned about automated charging. We looked at different transit fleets to understand how they function. We talked about autonomous vehicles and how they are developed. I hope this time was beneficial for you. Now I'd like to go to some questions. Are there any questions?
And we've got several questions here. Let me change the screen here. We'll start getting into some of those questions here. I trust that my screen is visible.
I don't think so. I think you're still sharing mine.
All right.
Let me.
Get this back up here. Before we get into the question and answer piece of this, and we have had a number of questions come in, I do want to alert everybody, and if this isn't your first webinar with us, you may have learned about the upcoming rebate that LES will be offering due to the generous grant that we received, $120,000 from the Nebraska Environmental Trust. That is going to be for rebates totaling $4,500 for first-time purchases or leases of a new all-electric vehicle. Those purchases made on or after September 1st, or $1,500 rebate for first-time purchase or lease of a new plug-in hybrid electric vehicle on or after September 1st. The rebates will be available to LES residential customers only, with a limit of 1 rebate per household. Leases must be for at least 3 years. And when purchasing an all-electric vehicle, will require an internet-connected charging station along with the purchase of the vehicle. We'll be launching the rebate form on our website at les.com on September 1st, so be looking for that. And now I'll take a look at the questions because we've had a number of them come in here. Let me look at these here. All right, let's look at the questions here and pull that up. We've had quite a few. The first question comes from W. Don Nelson, and he inquired, why do superchargers slow down during the final quarter of the charging session?
Very good question. Typically what happens is right at the end, you need the resistance of the battery changes such that it won't take a lot in. And so typically the last 10% of the charge needs to more or less be trickled in. And trickle means you can still put some current in. You can't take it at 350 kilowatts. You'd probably have to take it at 10 or 15 kilowatts at the very end. That's just the nature. That's the nature of a battery.
The next question from Dave Rich, is the Nikola Badger a truck fuel cell H2 fueled? You mentioned the fuel cell for the.
Oh yeah, it is a fuel cell which runs on hydrogen. Nikola has put in a lot of money into actually generating hydrogen. They have big facilities that they're being able to make to harvest hydrogen for their fuel cells.
Daniel asked this question, Mark, with the wireless charging pad on the street you touched on, how does it transfer the charge? Does it function like the wireless phone charging that many of us now have with our mobile phones?
Yes, it's the same thing. Basically what you have, if you think about it, you have two coils. The two coils, as you run current through the coil, it actually creates a magnetic field. And the magnetic field then is coupled to the other coil that's on the vehicle itself, and it then induces current into the battery. And typically, for your cell phone, you're pretty close. In this case, you still got a 8 to 10 inch gap, but it's probably got less efficiency, slightly less efficiency than a conductive system, but they're nearly the same.
Question here about whether the China trade policies are affecting sales like BYD buses in the United States. Any interest in commenting on the trade issues going on right now between the two nations?
Yeah. To be honest with you, I don't know. I don't know what that is. I would imagine, well, I would imagine it does. At the same time, BYD, all these buses in the United States now are coming out of Lancaster, California. And so I would think there could be some influence, but I would imagine they're pretty autonomous, but who knows for sure.
Rob is interested in drag racing buses because he asks how many miles per hour can these buses run? What kind of rate of speed do you think these buses will get up to?
Yeah, I mean, I would, you know, I don't know exactly, but I would imagine they're 50 miles an hour. They will get up to 50 miles an hour. Their typical use, though, is pretty much in an urban setting, and they're going from stop to stop. And if I remember right, the data I collected, on an average, they go about 6 or 7 miles an hour. So
And of
typically,
course,
yeah, typically they're pretty slow, but I'm sure they can get up to 50, 60 miles an hour.
most of these buses are going to be either shuttling around airports and that type of thing, or just around town for transit
Yes.
purposes. So they're probably not going to need to go faster than 45 miles an hour or so most of the time.
Yeah.
Another question from Rob is, do you foresee it being possible to reduce charging time to 10 to 15 minutes when traveling cross country in the near future?
Yeah. Yes, it's beginning to happen. I know I'm on a committee right now. You know, we're talking here 350 kilowatts is the way those buses are being charged. Well, right now there's a committee that are actually looking at building a 4,500 kilowatt charger as a manual connector. So basically, somebody can come up to the same, plug it in, and for 4.5 megawatts, um, they can charge very quickly. I know Tesla is looking at they want on their big pickup on their big over the road, they want to fill up a 500-mile range battery in 30 minutes. Yeah, that takes 1.6 megawatts. And so it's happening. That will happen. And I think it'll happen probably in the next year or two.
New challenges for the electric industry, right?
Yeah.
Amount of power.
Lincoln can do it though.
Well, we are one of the sites. You showed the map of the different mass transit, the bus pilots. We are one of those sites, the one in Nebraska, where I believe we have 2 or 4 all electric buses have been in town for since the start of the year. So we'll have to see how that all works out.
Absolutely.
Marcia asks, is it reasonable to think the autonomous vehicles will be highly entertaining for hackers? And how can systems possibly be built to safeguard from the threat? So is there concern about cybersecurity as it pertains to autonomous vehicles?
Well, and I think you hit the nail on the head. I mean, obviously most computer systems today are very hackable, and it's however, you know, you look at the auto industry, and somehow the auto industry is kept hacking out of their controllers, which is a good thing. But the one thing that they don't allow is for somebody else to put some software into their controller, and that helps a lot to be able not to be hackable. And the other thing is, to me, with autonomous driving, if it would be nice if overnight all vehicles could adapt and understand where the other vehicles are. Up until, because right now, an autonomous car has to be very defensive. You know, cars around it won't know that there's one there, and it's got to figure out where it is and how it is. So there's lots of development that needs to happen. Thanks for the question, though.
I got a couple questions about the LES rebate, which I'm going to get to here at the end. Is similar EV technology under development for motorcycles? Chris wants to know that.
You know, I've heard of some motorcycles being out there, but I haven't seen much on motorcycles at all. I do know, and I've been watching these. There's boats and ships that are that way. Matter of fact, the Maid of the Mist at Niagara Falls in New York. They have just launched 2 Maid of the Mist as being all electric. I saw them back last fall as they were being built, and I think they've just had their maiden voyage. They were supposed to be out earlier this year, but I think COVID stopped that. But there's all kind of ships. The other thing that I'm still amazed at, there's also airplanes that are coming, airplanes and ships and
All
you
kinds
name it.
of different modes of transportation.
Yes.
I do know we've had an electric motorcycle exhibit at our Sustainable Living Festival in the past. So I'm pretty certain that there's even a local dealer that sells electric motorbikes here in town. So somebody might want to Google that for interest if you're interested in that type of technology. Dalton wants to know if there are any health risks associated with the large inductive transit vehicle charging pads.
Well, the word on the road, I mean, on the street right now is no. First of all, I mean, it's sort of buried. It is buried underground, and there's been a lot of testing, and a lot of people are definitely interested in doing that. And they have curtains, magnetic curtains they put around this thing to shield it from getting out of underneath the vehicle. So if they can contain it within the vehicle, and again, I think there are standards for what those what that radiation or what those magnetic fields are should be, and so they are constantly developing or understanding and making sure that that is not an issue.
Last question I have here is from Kurt. How long do battery costs need to go? It probably means how low do they need to go to really tip the scale on the market? What are the prospects of getting there?
Well, you know, prices have been going down. Myself, I see that they're attempting to come to a plateau, but they're still coming down. And to me, that has been the problem. You know, two problems with electric vehicles are really the cost of the battery and that the amount of energy in the battery. So the bigger the battery, the more energy you have, the farther it can go. But the more you put on, the more it costs. So prices are still coming down, but they're, again, in my eyes, they're starting to flatten. So.
Well, thank you, Mark. Your presentation has been terrific, and we've had a lot of great questions posed to you. I had a couple questions about our rebate. How long do you expect $120,000 to last? Well, that's the $120,000 question. It's a first come, first serve. It's really hard to tell. It really does depend on the mix of folks who want all electric at $4,500 rebate versus the $1,500 plug-in hybrid. So it's really hard to tell right now. You know, my gut suggests it's going to last for a few months at least, but I guess we'll find out. This is the first of its kind here in Lincoln, and so we'll find out how that'll go. And then there was a question about whether we'd look at providing incentives or look at putting in higher than level 2s in homes for charging. And at least as my experience, the level 2s are really operating well for folks at home because the discharge of a battery is not well below 50%. We're a 20-mile round trip town for the most part. So people are doing quite well with level 2. Some even just plug into the standard 120 outlet and do that. But level 2 is pretty common. And I don't know if there's a really dramatic need right now to be pushing anything above that. Of course, then you start talking about needing to change services, transformer issues. So we're hopeful the level 2s will work for the foreseeable future.
Yeah, Mark, one thing with that, if you go with the level 2, you can actually go up to 19.2 kilowatts.
Higher than, yeah.
That's, you know, typically they're at 6 kilowatts, but in my garage right now, I have 14.5 kilowatts, and it makes a difference.
Yep, that's another aspect of it as well. I would like to thank everybody for participating in our webinar series. This is the fourth and final webinar on electric vehicles, and you will be given the opportunity to provide a brief feedback on a survey immediately following this webinar. If you have the time to do that, just takes about a minute, please do. Otherwise, you're going to get an email tomorrow. That email will have a link to the survey, but it'll also have links to the slide deck that you just saw, as well as a replay of this webinar. So we invite you to look at those again. We invite you to les.com/EV, where on September 1st, we'll have information about the rebate, the actual form, as well as there is a form you can complete to join our LES EV interest group, which is over 160 customers right now. So again, thank you so much for participating in this webinar series, and we look forward to keeping engaged with you throughout. Thank you so much from the Lincoln Electric Building downtown. Good afternoon. Have a great day.